Our last day of Unit 3, our last day of material for Unit 3. On Monday will be our Unit 3 test. I have that sent out to your school, so it should be there now for you. Once again, just as our other tests, we will take just 1 hour of class on Monday to do that test, to start the test, but you may have extra time. You will have to set that up with your person at your school because it's not one you can take out of the classroom and complete on your own and bring back. You do have to complete it in a classroom setting of some sort, but you can take as much time as you need to finish it as long as it is returned to be by April 24th. So you do have a full week there to find time to continue working on it. Hopefully at the end of class today, we'll have a few minutes. I can review some of the stuff from the beginning of this unit because we have covered a lot here in Unit 3. And as I've mentioned more than once, this is material that I don't expect that many of you have seen before. The mathematical concepts are familiar to you, but the applications and the medications and the medical side of it is stuff that is going to be new to most of you. So today we have one last thing to wrap up. We're going to be talking about something called safe dosages. And what safe dosage calculations really mean is pretty much double checking the doctor's orders. So the doctor makes an order and they are responsible for that order, but at the same time, you're the person who is administering the medication. So you're kind of that last line of defense of making sure that what the doctor recommended or what the doctor ordered fits in line with what is recommended for that medication, whether it's in a reference or on the label of the medication, just to verify that it is safe or verify that it is in the recommended range. So like I said, you're kind of that last line of defense and you're the one who's going to be administering the medication. So it is partially your responsibility to make sure that it is safe. So let's go ahead and look at some calculations or some examples here. Safe dosage calculations kind of can encompass any type of dosage calculation we've encountered, but most of the time it's dealing with a medication, an order that is based on some characteristic of the patient. So it's by weight, by body surface area, or some other qualification, so that there's that room where it can be double checked against the standard. Many other medications just have a flat out safe dosage. You just have to look it up. Like ibuprofen really doesn't depend on weight or any characteristic of the patient. There is just a set amount that is safe to administer during a 24-hour period before you start having liver and kidney damage and other things. So we want to make sure what we're looking at today is just the ones that involve calculations because of some characteristic of the patient. So our first example, we'll look at the doctor's order, is to administer 40 milliliters every 6 hours of this medication. And so we look at the label to find the recommendation, and the recommendation is 6 to 8 milligrams per kilogram every 8 hours. And it is constituted at 25 milligrams in 4 milliliters. Now I kind of combined two things here on the label. This is the recommendation. If you were to either find it on the label or look it up in some sort of a reference manual. I'm just putting it all as being on the label for the examples today. And then of course we have a patient whose characteristic is that their weight comes in at 77 pounds. Now if you recall, when we did our dosages based on weight, since these are all per kilogram here in the recommendation on the label, first thing we have to do is convert the patient's weight into kilograms. Get from pounds to kilograms, we divide by 2.2. So if we take 77 pounds divided by 2.2, we get 35 kilograms. And that is the number we start our dosage calculation with, is that 35 kilograms. So we take that 35 kilograms over 1, and of course, we start by getting rid of the kilograms. And we're going to use the max dose as usual. So that is 8 milligrams per every kilogram, per 1 kilogram. So the kilograms cancel out. On the other side, we got to get rid of the next step, we've got to get rid of the milligrams. We have 25 milligrams in 4 milliliters. So the milligrams will cancel out. We're now in milliliters. That's what we want for our patient. So let's go ahead and calculate this out. 35 times 8 times 4 is going to give us 1,120, and that's milliliters is our only unit on top. On bottom, 1 times 1 times 25 is just 25. So then we'll divide that out. 1120 divided by 25 gives us 44.8 milliliters. Now, once again, the thing that we have ignored here is the time frame. This recommendation is per 8 hours. That's what we use to find this. So this is calculated per 8 hours. The doctor's orders say to give it every 6 hours. And you recall we've discussed this a couple times before, that it's okay to give a smaller dosage more frequently. That's always okay. Not okay necessarily to give a larger dosage less frequently. So here, the 6 hours is a shorter period of time, so it's more frequently. It'll be 4 times a day instead of 3 times a day. So it'll be a smaller dosage. So it is okay to use the 6 hours, but we do have to adjust this dosage to be 6 hours, a 6-hour dose instead of an 8-hour dose. So we have to do a titration. We're going to change this to 6 hours. So we'll start out with the 44.8 milliliters, and that dosage is based off of an 8-hour dose. We're going to change it to a 6-hour dose. So the hours cancel out. Recall, as always, those two units in there have to be the same, so they will cancel out. We take the 44.8 times 6 divided by 8, gives us 33.6 milliliters, and that's going to be every 6 hours. Now, this is the maximum dose. We want to find the minimum dose to get a recommended range here. So to find the minimum, we take that 33.6 milliliters. And now we're going to do a different type of titration, same process, but we're now adjusting it for the recommendation. So this was off 8 milligrams per kilogram. We want to change it to 6 milligrams per kilogram. Now in practice, I probably wouldn't write these units in. I'm writing it in here just so that we can verify they're the same unit and see that they cancel out. So once again, we'll take our 33.6 times 6 divided by 8, get a minimum of 25.2 milliliters every 6 hours. It's our minimum. So here we're going to get a recommended range . 25.2 milliliters every 6 hours to 33.6 milliliters every 6 hours. Now let's double check that with the doctor's order. The doctor ordered 40 milliliters every 6 hours. 40 milliliters is outside of this range. So what does that mean? Well, we can't just change the dosage. We don't have that authority. Only the doctor has that authority to change that dosage. So you would have to contact the doctor or the doctor's representative. Usually the doctor has a specified nurse to contact. And you would have to double check that order. Notify them that, hey, double checking this order, something doesn't look right. Can we discuss it? And they would either say, yep, you're correct. We're going to give you permission to change it to this dosage. Or they may want it somewhere in between the 25 and the 33.6 to give them a mid-range dosage. I hesitate to say that the doctor was wrong. I don't ever want to say that because there might be reasons why this dosage is what they want. There are sometimes reasons, there's special cases where you do exceed the recommended dosage. Just on a short term, you don't want to do it consistently. But like for an infection, you might do an elevated dosage of antibiotics to shock the system and beat back that infection to start off with. And then before you reduce it down to the standard dosage to keep fighting off that infection. So there are potential reasons why you may want that extra large dosage. It may be a patient that's received this medication several times in the past and has built up a resistance or other things that come into play there. So we don't want to just change it without contacting the doctor and making sure everything has been considered. Other reasons why I don't want to just come out and say that the doctor is incorrect here, because there's legitimate reasons for honest mistakes. For example, up here we see our first calculation here was 44.8, but that was based on every 8 hours. So it could just be a typo on the part of the doctor or whoever was filling in the chart for the doctor, or the doctor may have just mistaken it, had read it wrong, thinking 8 hours and said 6. For an 8-hour dose, the 44.8 would have been perfectly appropriate for this patient. So there could be a mistake made that way. Other possibilities could be a change in supply. This is very common that you run into this, where the last time the doctor gave out this order, the concentration, it may not have been constant. Instead of being 25 milligrams in 4 milliliters, it might have been 25 milligrams in 6 milliliters. So now that would drastically reduce the amount of medication that the person is getting in a 40 milliliter dose. So if it was 25 milligrams in 6 milliliters, the 40 milliliters would be well in the middle of the range, actually towards the bottom of the recommended range. It would increase the volume of medication that would have to be given to get the same number of milligrams of medication in that dose. So there are things like that where the supply changed, or even it could be that at the beginning the supply was one, and as this patient stayed in the hospital, that supply ran out, and you had to bring in a new bottle or a new crate or whatever, and that new bottle had a different supply. And this is one of the main reasons why we double check dosages, is because of that. If we have to switch to a new bottle because we ran out, that new bottle could have a different concentration. So we have to verify that this is still correct and then adjust if necessary. So I'm not necessarily saying the doctor was wrong here. I'm just saying, given the supply we're using right now, that is outside the recommended ranges. Other little mistakes happen, like one of the mistakes I'll see on the exam is not converting the weight in pounds back into kilograms, or incorrectly converting it. So there's all sorts of spots for errors to come in that wouldn't necessarily be the doctor blatantly doing anything wrong there. Me being a numbers cruncher, I'm the math side of this. I do a lot with statistics, and one statistic I can share with you that's really kind of scary is that for patients staying 2 or more nights in the hospital, so extended stay patients, usually 1 night is considered just a standard stay. Surgery, recovery, release the next, surgery, stay the night to recover, release the next day. So 2 or more nights would be an extended stay. The statistic there is 1 in 6 either receive the wrong medication completely or the wrong dosage of that medication. And again, part of that is, they don't just have a dedicated bottle for you for that medication. All the patients in that wing, in that ward that are receiving that medication are going to get the medication out of the same bottle, so it gets used up and doesn't spoil or go stale on them. So it's very possible that if you're there for more than a couple of days, that's going to get used up and switched to a new bottle. And just what we talked about, the supply being different, the concentration being different in that new bottle, can cause the medication to be incorrect and not get caught. So that's why we have to double check those medications, is for that very reason. That is the most common cause of incorrect medications, is grabbing a new bottle and not realizing that the concentration in that bottle is different from the one that was being used previously. Okay, so our next example. We're going to have an order for 5 milliliters twice a day. And the combination between the label and the recommendation is that you receive 250 to 300 micrograms per kilogram per hour. The concentration in there is constituted at 5 milligrams in 2 milliliters. And our patient is 88 pounds. But once again, our first step needs to be to convert our pounds into kilograms. So we're going to divide by 2.2 here. 88 divided by 2.2 should give us 40. And there it is, 40 kilograms. So that's where we'll be starting our other calculation here. Our 40 kilogram patient, we'll just put that over 1. Getting rid of kilograms, we'll use the maximum recommendation of 300 micrograms per kilogram. So the kilograms cancel out. Well, we need to get rid of the micrograms, and we notice that nothing else in our label here has micrograms in it. So we're going to convert to milligrams. We know that from just our standard conversions, 1 milligram is 1,000 micrograms. So the micrograms have canceled out. We're now in milligrams. And now as we look at our label, we see that we have 5 milligrams in 2 milliliters. So milligrams on bottom, so they cancel out. 5 milligrams and 2 milliliters. And of course, milliliters is what we're going to be administering to our patient in this case. So we have 40 times 300 times 2, which is going to give us, I believe, 24,000, but I'm going to double check that. Oops, wrong button. 40 times 300 times 2, and it is 24,000 milliliters. Over 1 times 1,000 times 5, that's going to be 5,000 down there. So we're just going to divide that out. 24,000 divided by 5,000 is going to give us 4. Oops, I got an extra 0. So it's just 4.8. I missed a 0 in my division there. I divided by 500 instead of 5,000. So the number is 4.8 that we want here. So 4.8 milliliters. Now again, we look at the time frame. This is per hour. Up here, the doctor is saying twice a day. That is every 12 hours. Now, one thing that we've discussed, we've mentioned, it's not always okay to go to a larger dose, less frequency. This is saying to administer every hour. We need to double check to see, does it really mean to administer every hour? Or is it okay to concentrate it in 2 or 3 dosages a day so that you don't have to administer it every hour? In many cases, that's the case. They just list the recommendation as per hour, and they expect you to group it up into larger dosages and not give it every hour, not give it 24 times a day, partly because the patient needs to sleep. So if it's an oral dose or something like that, you don't want to wake them up to take their medication. Anyway, let's change this. This is every hour. We want to change it to 12 hours. So 4.8 milliliters. This is given per 1 hour. We want to change it to 12 hours. Hours cancel out. Well, this is going to be 4.8 times 12 divided by 1, which is going to give us 57.6. I should put my decimal point in there. That's 57.6 milliliters every 12 hours. That would be our maximum dose. To find the minimum, we're going to take that 57.6 milliliters, and that was based off of 300 micrograms per kilogram. we're going to change that to 250 micrograms per kilogram. So again, those units cancel out in the titration ratio as always. We take our 57.6 times 250 divided by 300. And we get 48 milliliters. That's been per every 12 hours. So here, the recommended range is 48 milliliters every 12 hours to 57.6 milliliters every 12 hours. Doctor ordered 5 milliliters every 12 hours, twice a day. Obviously, there's a couple of things to double check here. First is it okay to concentrate this into one dosage every 12 hours, or should it be given every hour? Second is, okay, the 5 milliliters twice a day is way too small. It's way outside this recommended range of 48 to 57. So check to make sure, did the doctor mess up and write down twice a day when they meant it was every hour? Of course, even twice a day, it would be a little large because it was or even every hour, it's a little large because it would have been 4.8 per hour would have been the max. But something appears to be off in this. So again, you'd have to double check with the doctor and get some sort of advice on how to correct that dosage. Well, we have dosages based on body surface area as well. So let's look at an example here where we have an order. We're not going to body surface area quite yet. We're going to go through our dosage over time first for body weight. So rather than being administered in single dosages spread out, we're going to do a continuous dosage through IV. So our order is to run the medication through IV at 20 drops per minute. And our label shows that the recommended dosage is between 8 and 10 milligrams per kilogram per hour, and a concentration of 25 milligrams in 8 milliliters. For drop factor of 12 drops per milliliter. And of course, we need our patient. Our patient is going to be 66 pounds here. So again, our first step is to convert our patient's weight to kilograms. We're going to divide by 2.2. 66 divided by 2.2 should give us 30 kilograms. So that's where we start our calculation. So our patient of 30 kilograms, we're going to start with our max, which is the 10 milligrams per kilogram. So kilograms on bottom, 10 milligrams on top. Kilograms will cancel out. We need to get rid of the milligrams. We have 25 milligrams in 8 milliliters. So the milligrams cancel out. Now, normally if we're giving single dosages at given intervals, this is where we'd stop, is how many milliliters would that dosage be? But we're going to do this over time in a continuous IV, so we need to get that down into drops. So the milliliters are going to cancel out, and we're going to use the drop factor, 12 drops in 1 milliliter. Those milliliters cancel out, and let's go ahead and multiply this out. So we'll have 30 times 10 times 8 times 12 drops. It's going to give us 28,800 drops. On bottom, 1 times 1 times 25 is just 25. So we'll divide that by the 25. You get 1,152 drops. Well, how's that spread out? This was per hour for the recommendation. So this is going to be drops per hour. So all we have to do now is to convert that into drops per minute. Take our 1,152 drops over 1 hour. I have to get rid of hours, so I'll put 1 hour on top, going into 60 minutes. So the hours will cancel out. On top, we just have the 1,152 drops. On bottom, we just have 60 minutes. So we divide out the 60 there. We get 19.2 drops per minute. Well, the doctor had ordered 20 drops per minute. This is really close. Might be slightly over it is slightly over the max, so it's something to double check. Before we continue, let's find our minimum. This is the maximum dose. So before we contact the doctor, we would want to find the minimum dose. Partly because, in order to save time, we want to communicate with the doctor. This is what we calculate the recommended range to be. Do you want to change this to be somewhere within that range? So the minimum, we're going to take the 19.2 drops. And that was calculated on a maximum recommendation of 10 milligrams per kilogram. And we're going to turn that to a minimum of 8 milligrams per kilogram. So again, the milligrams per kilogram cancel out. We'll take the 19.2 times 8 divided by 10, giving us 15.36 drops per minute is our minimum. So here our recommended range is 15.36 to 19.2 drops per minute. And as we mentioned, the 20 drops per minute is slightly above that range, but it's pretty close. So it might be just the doctor was rounding off. Chances are that's within the safety margins. But once again, you'd want to contact the doctor and say, hey, this is what I calculated the recommended range to be. Do you want to stick with the 20 or do you want to adjust it a little bit to be in that range? So now, as promised, we'll move on to body surface area. So let's look at an order that is 2 milliliters every 8 hours. And for a label on our supply that says 7 to 8 milligrams per meter squared. So this is body surface area. We're looking at square meters of surface area rather than pounds of weight or kilograms of weight. And that's per day. And it is constituted as 5 milligrams in 4 milliliters. Patient. £70 pounds and 47 inches tall. Step one, just like before we had to convert the pounds into kilograms, here we have to convert the height and weight of the patient into a body surface area. And for pounds and inches, the number of square meters is going to be the inches, 47, times the pounds of 70, divided by 3,131. So we punch that in our calculator. Square root of 47 times 70 divided by 3,131. And we'll close up our square root. We get 1.03 meters squared. So our body surface area here is 1.03 meters squared. That is what we will use to start our calculation. So 1.03 square meters over 1. We're going to get rid of the square meters. Again, we'll use the maximum recommendation, the high end of the range. That'll be 8 milligrams per each square meter. The square meters cancel out. We get rid of milligrams here. We have our concentration. It's constituted at 5 milligrams in 4 milliliters. So the milligrams have canceled out. And this is going to be single dosages given at intervals. So milliliters is the units we want here. So we start with our 1.03 times 8 times 4 gives us 32.96 milliliters. Over on bottom we have 1 times 5 times 5, so it's just 5. Take our 32.96 divided by 5 gives us 6.592. We're just going to go 6.59 milliliters. And that was per day. Doctor wants it given every 8 hours, so we have to do that titration. We're going to change it to 8 hours. We're going to take 6.59 milliliters. We're changing it to 8 hours. So the reason I put that in first is rather than putting 1 day in bottom, remember these units have to be the same, so this has to be in hours. So I'm going to express that as 24 hours. The hours will cancel out. 6.59 times 8 divided by 24 will give us 2.20. Milliliters per 8 hours. And again, that is our maximum dosage. Find the minimum. We take that maximum, 2.20 milliliters. That was figured off of 8 milligrams per meter squared. We're going to change it to our minimum range of 7 milligrams per meter squared. The milligrams per meter squared cancel out. We take our 2.2 times 7 and divided by 8. It's going to give us 1.93. Now I'm just automatically rounding these to 2 decimal places. Hopefully at this point in the course that's not a problem. That's milliliters, and our time frame is still per 8 hours. Was our minimum. So our recommended range is 1.93 milliliters every 8 hours to 2.20 milliliters every 8 hours. And just to review, the doctor's order was for, where'd it go? 2 milliliters every 8 hours. So that's pretty squarely within that range, slightly to the low end, but actually fairly close to the middle of it. So that's a safe dose. So that's one that we can go ahead and administer to the patient without having to worry about double checking anything with the doctor. So we may come back to more of those safe dose calculations, but before I do that, I want to make sure that we go over a couple of things that will be on our test on Monday that have been a ways back in the course. The first topic we covered, which is actually kind of the source of many of the calculations we've done, even a lot of the ones we just did, is dilutions. Remember, a dilution ratio, for example, if I have a 2:7 dilution, that 2:7 is a ratio. But the thing to remember is that 2 represents the parts of serum. Remember, serum is just our active ingredient, whether it's a medication, an antiseptic, it could be just salt and water, iodine, whatever our active ingredient is in this case. And the second number, in this case the 7, is the total parts of solution. So if I wanted to say how much iodine is needed to create 350 milliliters of a 2:7 dilution, well, the iodine is the serum, so that's going to go with the 2. Oops, sorry. The iodine is the serum, so that goes with the 2. That's what we're looking for, so that's going to be our missing number, the X. The 350 milliliters of this dilution, that is the amount of total solution. So the 350 milliliters goes on bottom. That's what the 7 represents the total solution. Now we'll cross multiply. 2 times 350 divided by 7 gives us 100 milliliters. So it would take 100 milliliters of iodine, and then we would fill with neutral solution or normal sterile water up to then the 350 milliliters to complete that dilution. Well, these dilutions could be used for a lot of things. One of them is to reduce concentration. So let's say that we have a solution that we want to find the new concentration of. If, let's do a 42% solution is diluted 1 in 6. So we have our 1 in 6 dilution. And remember, the ratio 1 in 6 is the ratio of the diluted solution to the concentrated solution. So the concentrated solution is going to be the larger percent, the larger, higher concentration. That's the 42%. That's going to go on bottom. And again, as always with a proportion, we cross, multiply, and divide. So 1 times 42 divided by 6 gives us 7% will be the new solution after it is diluted. Another application for these dilutions was in testing. So let's say we have a sample of blood that exceeds the meter limits. So we test the blood and the meter says error or limit is exceeded. So what we're going to do is we're going to combine 5 milliliters of blood with 10 milliliters of sterile water, of NS, normal saline. Then we test it again, and the new reading is 387 milligrams per deciliter. This is a blood glucose test. So find the true reading, or the true level. Well, to find that, the first step is to define the dilution. So our dilution here is we had, the blood is now our serum. That's what we're testing. There's 5 milliliters of that. But remember, the second number here is the total solution. So that's the 10 milliliters of saline plus the 5 milliliters of blood. So this will become, the milliliters will all cancel out. This will become a 5 to 15 dilution. Now we can reduce that to a 1 in 3 if we want to, but we really don't have to. We can continue with that 5 and 15 here to now correct our reading. So the meter reading here is going to be smaller than the true reading because we diluted the blood. So the meter reading always goes on top here with a smaller number of the dilution. This is 387 milligrams per deciliter. Cross, multiply, and divide. So 387 milligrams per deciliter times 15 divided by 5 gives us 1,161 milligrams per deciliter. So that is the true reading for that patient, the true level in the blood. One of the other things we did was we did our change of concentration or concentration adjustment formula. Up above, we used the dilution to reduce the concentration. But rather than going through just doing a dilution, we can save ourselves some calculation by using that formula. The concentration 1 times volume 1 equals concentration 2 times volume 2. So we might ask, find the new volume. If 120 milliliters of 18% solution is to be diluted to 4%. So again, on the left side of this, we'll deal with what we started with. 18% is our concentration. Now I could either put that as 0.18 or I can leave it as 18. It really doesn't matter as long as I do the same on the other side of my formula. So 18% times 120 milliliters equals, on the other side we have 4%. So since I left that as an 18 on the left side, I leave it as a 4 on the right side. And that's going to be times my new volume. So to calculate this out, I do my 18 times 120, which will give us 2,160. Then I divide by the 4. So is that 540, I believe? It is. That's 540 is our new volume. Now, since the first volume was in milliliters, this volume is also in milliliters. So the new volume will be 540 milliliters of that solution. So we would take our 120 milliliters of the 18% solution, put it in a graduated cylinder, and fill with sterile water until we get up to a volume of 540. And we know that at that point, it is now a 4% solution. And then, of course, we also looked at the different types of concentrations. Different concentrations, of course, could be a volume and volume, weight and weight. Really, it's mass and mass because we deal with milligrams and milligrams or whatever, but we still use the old connotation of weight and weight. Or weight and volume. And the big thing to remember in weight and volume is the weight will be in grams compared to a volume in milliliters. So be careful with that. Because remember, 1 milliliter of water is the definition of 1 gram. And since most of our fluids are going to be close to the density of water, the weight is in grams, even though it's technically a mass, compared to milliliters for the volume. So with that, I don't have the page in front of me right now, but we're just going to finish the chapter in the homework and review for test. So again, on Monday is test 3. You have the hour to complete it. You'll have whatever other time you need. Again, it's unlimited time, but we do have, as long as they are submitted back to me by April 24th. So you have 1 week of time to finish it outside of class if you don't get it done in that hour. As I said, this is the one test that students really struggle with the most because it's topics you haven't normally seen. So with that, you guys have a great weekend, and we'll see you all back here on Monday.